Good morning, my little 7th graders. I am going to video you my anchor charts. I've wrote them for you nice and neat, sort of. Nice and color coded. You can see my addition problem. I forgot the addition sign, I see. You've got an addition problem here, and I'm grouping to 10. So like 7 plus 3 makes 10, so there's 5 left over. I didn't finish this problem. I'm not really interested in finishing it. I'm looking at how my work looks. In this column here, I could have taken that 4 and given 2 to 8 and 2 to 7. That made that a 10, and that would be a 9. And then this column here, I could have called that a 6, a 6, a 6, and then added 2 more, or I could have called it 3 sevens, subtract 1. Again, adding two groups of 10, multiples are trade and exchange. Question 2. You've got your old way of subtracting. Typically go next door and borrow, and we don't say borrow 1, we need to say give 10, we don't give 1. The new way down here would be boxing in 60 and drawing a line through it, and if you borrowed from 60, if you take 1 from 60, 59 is left, and if you take 1 from 400, 399 is left. If you look at the difference, lots of borrowing, only 2 steps for borrowing. You get the same answer, you decide how much work you want to do. Here's my second anchor chart. I'm looking at subtraction with decimals, adding and subtracting. And then over here I'm looking at multiplying. So let's look at this half first. You've got 36 minus 7.42. So $36 subtract $7.42 if you think in money. Now if that's the case, $36 should be wrote 36.00. 7.42 goes underneath it. Watch your borrowing. Again, I tend to use that squaring off, so it seems to work nicer for me. That is a new process, kind of a new way to do that. This one down here. So if this is your math problem right in here, 4.34, which is 4 and 34 hundredths, plus 45 plus 7 tenths. Now, that's $4.34. You know that. 45 what? $45. And that's 0.7. 0.7 is not money. That's $0.07. It says so right here. So if I add all those dollars up, $4.34, $45, 0 cents, $0.70, you would get this answer. Or if you add nice things together, that whole number plus change would make 45.70, and you would only have 2 numbers versus 3. It's kind of your choice. How much work do you want to do? And that's kind of a new idea for us anyway. Next, what about over here? You got regular old multiplying. 43 hundredths times 72. Well, typical multiplying, 3 times 2, 6, 4 times 2, 8. Bring down a 0 because your teacher told you to. 7 times 3 is 21. 7 times 4 is 28, plus 2 more is 30. Add those together, bring your decimal place back to 30.96. So $30.96 or 30 and 96 hundredths, depending on how you want to read that. But what if I did that with lattice and not lettuce? So if I draw a window, pretty much a window, to put your little diagonals in, kind of a cat scratch, we talked about that in class, and that one goes on top, that one goes on your right, and it wouldn't matter. And then start multiplying. Remember, this box here is 3 times 7, this box here is 3 times 2, this box here is 4 times 7, and this box here is 4 times 2. So 21, 6, 28, and then that is 8. Remember, if you want a single digit, you need 0, 8. So you start adding from my right going toward my left. So that's 6, 0, 1, and 8 would be 9. 0, 8, 2 is 10. Carry my 1. 2 plus 1 is 3. Remember, this is the ones place, the tens place, the hundreds place, the thousands. It's a place value. And if I swing the decimal back twice, there she is. Same answer, same idea, just a little different way of getting there. I will share more anchor charts with you as we progress out this year. Division. We all love division. Alright, maybe that's a stretch. If I think about division, you need to really think about it being more of a multiplying and subtraction process, not a division idea. So let's look at my math problem. I have 4,192 divide by 7. So if you look to this far right over here, these are actually my thinking sentences. So I'm not going to say 7 goes into, there's no goes into, it sounds like you're sneezing. How about 7 times what is 4? So 7 times what is 7 times what is 4? Well, 7 times 1 is 7, and that's too much already. It max is 4. So that's going to be a 0, and I'm going to put that 0 there. That's a good placeholder. Next. So 4 didn't work. How about 41? So let's try again. 7 times what's 41? Because I'm using both numbers now. Well, if you know your 7 facts, 7 times 5 is 35. 7 times 6 is 42, and darn, you missed it. It's going to be 5. Now this 5 goes on top, and this 35 goes on the bottom. So the 5 goes up here, 35 goes down here, subtract 6, bring down 9, start all over. 7 times what's 69? Well, 9 times 7 is 63, and that's as good as you can get because you can't get anything bigger than 9. So I'm going to put the 9 on the top. I'm going to put the 63 on the bottom. There's your 9. There's your 63. If you subtract, 9 minus 3 is, yep, 6 it is. Bring down 2, 62. It's right here. 7 times what's 62? How about 8? 7 times 8 is 56. So this one goes on top. This number goes on the bottom. I subtract, and actually if you notice I don't have any borrowing. I count up. I know from 56 to 60 is 4, and 4 plus 2 is 6. Now, we're almost done. This leftovers is my numerator, and the number I divided by is my denominator. So the answer is 598 and 6/7. Again, I never divide. Always multiply and subtract. Well, I learned division. I know how to multiply and subtract. Perfect.